Okay, so this lecture is about file input and output. What we're going to cover, simple things, well, we'll just get into it. So, first thing, file objects. So a file object represents a file. Haha, how about that? Now, strangely though, there's another thing a file object can represent, and that is a directory. So a standard way to do it is you declare the file, as in here, file in file, and then you create it using a string either for the path in the local directory, so wherever your project is, this file would be sample.dat in that same folder, or you could create a new file with a complete file path, so C, sample programs, test.dat. Okay. Now, basic way you can use files, first thing we need to know about are streams. So a stream is basically a flow of data from one point to another. And typically, the endpoint is going to be RAM, right? The memory where your program is actually running. And the other endpoint, at least in this context, is going to be a hard drive. So an input stream is where you're reading memory from the hard drive to your RAM. An output stream is where you're taking memory, the data that's stored in RAM, and moving it to your hard drive. Okay, so all these input-output streams, they're relative to your RAM, not to other sources. Okay, basic classes for low-level file input-output are file input stream and file output stream. Both of those take data as an array of bytes. So it's just an unformatted mass of bytes, a byte array, that either you read a byte array from a file or you take a byte array you have in RAM and you store it. Okay, so simple example here. Let's do it. We'll go ahead and put it in this code. We'll call it file demo. Give it a main method. Okay, so when you're doing code with Java, for file input output, you generally want to import the entire java.io package because all these file objects, other things, they all use it. Okay, so the first thing we'll try to do is a save bytes. So save bytes, so save byte array. Okay, and let's say we're going to accept a file f as a parameter. So first thing we're going to do is we're going to have to specify the file. So we'll just copy all this into the workspace and we'll move it around a little bit. So also, we generally have to do this file input output stuff in try-catch blocks because one of the checked exceptions is this, catch IO exception. An IO exception is a checked exception, so we have to catch that. So here, I'm going to say static void save byte. So I'm going to say save byte array, and I'm going to save it as new file, and I'll call it fd1.byte for bytes. Okay, so I'm going to call this save byte array, and this is the file I'm going to specify. So what we will need to do is first set up our stream. So in this case, we already have the file. So we're going to say file output stream. Here we'll call it outstream like they do in the slides. File outstream is a new file outstream that we're affiliating with F. So set up stream to file. So anytime we pull some data from this file output stream object, the file output stream object behind the scenes is actually going to pull that data from the file, so we don't need to worry about it. So if I want to send a sequence of numbers, say in this case I'm doing 10, 20, blah, 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 all I have to do is call outstream's write method. So this file output stream, I call its write method, and I send along the byte array that I'm going to use, and then after I'm done, I close down the stream because it takes a certain amount of computer resources to keep it open. And down here I'll do system.out.println unspecified IO exception. Okay, so that's what I've got there. Now when I run this, right, I can go into my folder and verify that I don't have this file here. So let's go all the way up to desktop and up and up. And here we go. And we got app data, no, we got workspace, Okay, and in file 2019, we have a bytes.dat, but that's not the same one. That's one from an earlier demo. So when I run this, let's save it. We're going to run it. Boom, it's done. Okay, and now I can see I have my, oh, where is that? Oh, there it is, fd1.byt. It's a byt file. How about that? Okay, so let's do, we'll put in some messages so we know what stuff is actually happening. Print line starting application, and afterwards we'll do ending application, and here we'll do data saved successfully. Okay, we'll be more specific, we'll say byte array. Because in the exception, right, in the try block, if we make it all the way to the end, we know we did all the stuff before it. So run this again. There we go, starting application, byte array, saved, ending application. Okay, but saving data is all nice, but the other thing you need to do is to load the data. So if you're loading the data, it's a little bit different. For loading it than it is for other types. So let's go ahead, we'll make a new static void load method. Load byte array from file F. Okay, so this one, our file here, we already have the file, so we don't need that. So we're just going to say set up the stream, set up the input stream. Okay, we'll call that file input in stream is a new file input stream. We're affiliating it with our file F. So anytime we again call this method, we're going to have to send along file F. So we'll call this load byte array. Okay, and we're specifying the same file. So in our load byte array, we affiliate the input stream with our file F. And then next thing we need to do is we set up an array to read the data into. So our file size, we need to know how big the byte array is going to be. So one thing we can do with a file is we can call its length. Its length is basically the amount of data that it holds. So we're going to typecast that to an int because it can return a long, because files can be pretty big. We're going to typecast it to an int and say that's what our file size is. Oh, yeah, and I got to do this all in a try block. So you see here I have an error here because I didn't put all this in a try-catch block sequence. So and do this, try, and again I'll do my catch, this. Okay, and all this, let's shift right. Okay, so set up an array to read the data into. First I get the file size, and then I create the new byte array of that size. So that makes sense. Then I just read the data. So since I've set up the stream connects directly to the file. If I ask the stream for data, the stream's going to handle it behind the scenes and bring in all the data from the file object itself. So I call instream.read, and I specify the byte array that the data is going to go into. So what this does, this pulls a byte array, it sends the byte array reference to the instream object and says, read a bunch of data from the file, store what you can in this array. Okay, and then I can print out all the contents afterwards. So that's what happens here. So I have a loop starting from 0 to file size. One at a time I print every element in that byte array. And it'll be these same 8 values here, 10 through 80. If I run this, boom, there it goes. First I saved it, then I printed out the data. Then I end the application. Okay. So higher level file input output, you can do it 2 different ways. So data output stream is for sending numbers, basically primitives, and then we'll talk about object input and output streams for doing the same with objects. So if I want to save a bunch of numbers, okay, we can have a sequence here I'll just lift. So I'll make a new method. We're going to specify that it takes a file. Okay, so we'll do our 2 here. So static void load numbers, and I'll again use a file F, and static void save numbers, and again with a file F. So we'll do save numbers first, and we'll say save numbers, say new file, and we'll call it numbers 2.dat because I believe I already have a numbers.dat in my directory there. If we look, yeah, I already have a number. So I'll do numbers2.dat. Okay, so first thing I want to do, let's put a try-catch sequence in here. So try some stuff. We're going to catch an IO exception. And again, we're going to print out our standard message. Okay, now right now we have an error because it doesn't see anything that can throw that exception. So we're going to start, first of all, we're going to do file output stream, we'll call it FOS, the new file output stream, and we're going to affiliate with our file. So this is going to take our data and save it as a byte array to the file. But we actually want to save a bunch of numbers. So we are going to create a data output stream. Data output stream is a class that handles the processing, the conversion of primitive data types to simple bytes. So we're going to affiliate that with our file output stream. So basically, anytime we write something to this data output stream object, it's going to get passed along to the file output stream object. The file output stream object is going to pass it along to this file. So that's how we write things to our file. We just call dos.write and whatever data type we're talking about. So let's do this. We can write some stuff here. Okay, so if we want to write a bunch of values, and I'm going to replace all these. So okay, so here I'm going to write a bunch of values to my file. I'm going to write an int and a long. The L here just specifies that the number is type long. Same for the F, specifies that that's a float. Same for double, specifies that that's a double. Then I'm going to write a char, then I'm going to write a boolean. After I'm done, I'm going to close both streams. I'm also going to close fos.close. Okay, so this will write some data to my file. And then after that's all done, I'll say primitives saved successfully. Okay, so let's see, this should all work. Okay, primitive saved successfully, great. Well, the next thing I need to do is I'm going to load them. So once again, I'm going to use a file input stream. I'll do a try-catch block for this. Okay, and once again, file input stream, FIS is new file input stream. I'm going to affiliate it with our file. So when I call this method, I send along a file, it gets received here as F. I'm going to create the file input stream that connects to that file. Likewise, because I'm dealing with primitives, I'm going to create a data input stream object that connects to the file input stream object. Okay, so again, anytime I want to read something from the file, I call data input streams read methods. That passes along the request to the file input stream. That passes along the request to the file to get the data I'm asking for. Okay, so basically we can do this. I can read the values and then print them all out. And then afterwards I'm going to close that. I'm going to do DIS. Okay, and down here, I'm going to close out fis.close. Okay, so one at a time, I'm going to read back all the values that I input. I'm going to read an int and a long and a float and a double and a char and a boolean. Okay, just like I said there. Okay, so I read those, primitive saved successfully. Why am I? Oh, I didn't call the method. Haha. Okay, so load numbers, and again, this. It's going to go there. Let's save that. We'll run it. Okay, and I get now all the numbers that I saved. Wonderful. Okay, now a thing to notice, file input stream just brings back a byte array. It's unformatted. It's just a sequence of bytes. So you can actually read back the data in any form you choose. For example, this long is 8 bytes. I could replace that with 2 ints, right? So it's going to take those 8 bytes and just display them in a format of an int for each one. So the first one will actually be 0 because of the way the long is structured, and the second one will be the long value. Don't need to get into great detail about that. So that's the 2 extra ints there. But just the point is, you have to be careful with the data input stream that you read back the data in the primitives in the same order that you saved them in, because otherwise you're going to get some screwy data reversals. For example, if I take this char and put it at the start, right, that's going to throw off everything up until the Boolean. All these numbers are going to be totally different stuff, right? But at the end, I'll have true because that one stayed in the same order. Okay. Last thing for this, okay, so here's some stuff. There's different classes for saving text. Some of those, like print writer, are optimized to do string data, so they might do it a little faster, but we're not really worried about that for this class. There are other input-output classes and methods, but I'm never going to ask you about any of these print writer, file reader, buffered reader. Not going to ask you about those for the exam. Okay, but they do exist. Okay, and same for scanner. You can even use scanner to send data to files because it's a kind of stream as well. But in this course, we've only been using scanner for user input. Okay, last thing, object file input and output, or the last I/O stuff, strictly speaking. So it is possible to store objects just the same way as you store a primitive data value, which is a wonderful thing because an object can contain a whole bunch of data. Likewise, an array, which is an object, can contain a whole bunch of objects. So the ability to save an array in one shot is going to save you a lot of time and misery when it comes to writing these applications. Now, key thing, anytime you're saving data from an object, the class has to use the phrase serializable. So I'm going to put that in my code here. We'll create a new object. We'll call it class thing. Okay, and thing has 2 values. It has an int x and it has an int y. Okay, wonderful. And we'll create a constructor here. So thing that accepts an x and a y, int x, int y. And we'll say this dot x equals x, this dot y equals y. Okay, so anytime we create a thing object, we have that. Now, if I try to save a thing right off the bat, not going to be able to do that because thing is not serializable. Serializable is another interface but this one doesn't have any methods. So if you have trouble with the interfaces, you can check back to GUIs and event handling that used them earlier. I'm going to make these 2 methods then. So again, we'll have static void save object. Okay, and the other one, static void load object. Okay, so the system is basically the same. Number one, I'll make these that accept a file parameter. So once I have the file, again, I want to create a file input, a file output, stream object, FOS, equals new file output stream, and affiliate it with F. That's what I'm going to use to convert my object to a byte array and send that byte data to the file. I have to have this in a try block, of course. Okay. Second thing, I have the object output stream. So object output stream is a class that I can use to save my objects, convert objects to a byte array, and then save them to a file. So OOS, new object output stream, and I connect it to the file output stream. So anytime I want to save something, I just call OOS.WriteObject, and I send along the thing I want to send. Okay, so I can do that. OOS.WriteObject, and I'll say new thing, and I'll give it the initial values, I don't know, 56 and 99. So easy. And then afterwards I can close the streams. So os.close and fos.close. Okay, so let's see what happens when I call this. I'll do what file? I'll do save object, and I'll say thing. I'm making an obj file. Okay, so let's see what happens. I got an exception. That's from this particular one. Okay, I'll just verify that unspecified exception during object save. Okay, that's exactly what's happening. Okay, reason is this thing object doesn't implement serializable, so something goes wrong. So here I have to implement serializable, even though it doesn't seem like it does anything. That's what I have to do. Once I've done this, then I can save the object. Ta-da! See, no more exception message. So I'll do this, I'll lift this line, put it up here. Okay, I'll say object saved successfully. And if I want to read it back, I do the similar thing, right? So I do try, and then a catch IO exception E. Okay, and I do the same thing. I'm going to create the file input stream to interface with the file. And then I'm going to create an object input stream to interface with the file input stream. And then all I have to do is read the object, although there's a little bit of a wrinkle with reading objects. I call OIS.read object. Okay, that's going to get the thing. I'll say thing T equals this, because the thing I saved to my file is a T. But I have an error now. Number one, there's a type mismatch. So read object returns an object of type object. I have to typecast this to a thing. And now it's okay. I know that the thing that I saved was actually a thing, so there's no problem there. But now I get another exception. So we look at it, it says unhandled exception type class not found exception. Okay, so I got to catch that too. Class not found exception is basically one that says, hey, you're loading this object of some class. Why? Well, what am I going to do if I don't have a class definition for it? It's a strange thing because you shouldn't be able to compile the code without having a class definition, so I'm not sure how they work around that. But anyway, anytime you're loading an object from a file, you have to catch this class not found exception. What goes wrong, basically, if I don't have a thing object in place? So, class not found exception, let's say no class definition for thing available. Okay, now all my errors are gone. If I want to, I could print out system.out print line t.x and t.y. t.y. Okay, which we remember before were 56 and 99. And then I'll close the streams. So fis.close and ois.close. Okay, so if we run this, right, and we call the load object method, that's going to read that file and pull the object from it. So there we go. X is 56, Y is 99. We've read data. Now, this object reading works exactly the same way if you have, say, an array of things or an array of anything. There's some examples in the slides and on the code that's already posted up on Blackboard. So basically, for saving objects, you, again, set up the set of streams. So you have an object output stream connecting to a file output stream, which connects to the file. If I want to write something to the file, I call the out object streams write object method and send along the object I'm going to send. Okay. To read objects, again, you set up the streams. You connect an object input stream to a file input stream, connect a file input stream to a file object. And then if I want to read something, you just call the object input streams read object method. Two quirks with that. Number one, you have to typecast the object to the correct class type. And number two, you always have to have the I/O exceptions getting caught. But then for reading objects, you also have to catch the classic not found exception, checked exception. Okay, and it works exactly the same for arrays. For example, if you have an array called people, if you set up all your streams, you can just write people to your file as if it were an ordinary object, which it kind of is. And if you're reading one, if you're reading this an array of type person, then you just typecast your input object to a person array, and you're okay. All right. So some other stuff about files, some little catch-all stuff here. Number one, a file, even though we've talked about files as always being files, again, they can also be directories. So two things a file can be: a file and a directory. And here's a method that basically prints out the contents of a directory. So it creates a new file object. Since this one is a directory, the list will have the contents of everything in that folder, right? A directory is just an older term for a folder. We convert that to a string array. So the list method returns an array of all the contents of that directory. And so one at a time we can print every element in that file name array. And so we'll print out all the files and all the folders in that particular folder. Other stuff, there's a JFile chooser object that is useful for making pop-up windows. So there's an example of this in the code demos from earlier this week. I guess probably from last week. Anyway, so JFile chooser creates a little pop-up window that shows all of the files in whatever folder you choose. So if you say affiliate a JFile chooser with a particular directory, it'll open up by showing you all the contents of that directory. Other stuff, there's methods. When you close out the window, the ways you can close it out are, number one, either selecting a file to open, or number two, canceling to close the window. And if you if you select a file, then you can call choosers.getSelectedFile. It'll give you the name of the file that was chosen, the file object that was chosen. And then you can do things like show the file name or show the path to it, things like that. There are file methods. Look in here. So for example, just for files, you do f dot, what do we have here? We have get path, get absolute path, that's the complete thing, get name, all that sort of stuff. We can call these file methods to find out information about the file. Okay, but all you really need to know in regards to file choosers, so number one, we've used files as files, but they can also be directories. Number two, JFile chooser is just a little pop-up window, basically the same as this. It's going to show up all the things that are in that folder. Okay, last thing you can do with that, with JFile choosers, you can also apply a file filter. So if you want to only show certain types of files, file filter is an abstract class. There's a number of subclasses like file name extension filter that you can use to only show files with a particular extension type. So, all right, and that's what you need to know about file input and output.